Hello everyone. Today we are diving deep into one of the most important and misunderstood parts of modern programming, asynchronous programming. If you ever seen async and await in C# and thought, okay, I know it make my code faster, but how? This episode is for you. We'll break down what async await really means, how it works behind the scene, and how it helps your API stay fast, responsive, and efficient. The problem with blocking code. Let's start with the reason async exists. Imagine you call an API endpoint that takes data from a database. If the call takes 3 seconds and your thread waits doing nothing, your server just wasted 3 seconds of CPU time. That's called blocking. Blocking threads is like having a waiter who stops serving everyone else while one customer is waiting for food. It doesn't scale. Async await was created to solve that exact problem by letting your code pause and free up resources while waiting. How async works conceptually. When you use await, your method tells the runtime, I'm doing something that will take a while. Go do other work in meantime. Instead of freezing the thread, DotNet breaks your method into two parts. Before the wait, the setup. After the wait, the continuation. When the awaited task finishes, DotNet picks up where it left off. So async isn't about parallelism. It's about not blocking operations. You are still using the same thread pool. You are just not wasting thread waiting for I/O. The task object. Every async method in C# returns a task. Think of it as a promise to deliver a result later. A task can be one of three states: running, completed, faulted, error. When you await it, your method suspends until the task finishes. Example: var data equal await get data async. Behind the scenes, that line creates a continuation. When get data async is done, continue here. That's why async code looks synchronous but behaves asynchronously. I/O bound versus CPU bound. It's important to understand what async is good for and what is not. Async is great for I/O bound work, database calls, API calls, file reads. It's not for CPU bound work, heavy calculation, image processing, encryption. For CPU work, you use task.run to push the job to a background thread. For I/O, async await lets you free up the thread entirely. Example: await file.read all text async data.json. That call doesn't use CPU. It's just waiting for the disk. So async makes it efficient. The event loop and continuation. Behind the scenes, .NET uses something called the synchronization context or task scheduler to manage what happens after an await. When a task completes, the continuation, meaning the rest of your method, is queued back on the correct thread or context. That's why in web APIs, async code doesn't block other requests. The thread returns to the pool and serves another user in the meantime. Think of it like tag team cooking. While one chef waits for water to boil, another starts chopping vegetables. Async in ASP.NET Core. In ASP.NET Core, every request gets a thread from the pool. If your endpoint does something like await service that get user data async, that thread goes back to the pool while waiting for the database. When the call completes, the continuation resumes on a free thread. That means the same number of threads can handle many more concurrent requests. That's why Async API scales so well. Now let's talk about what can go wrong. Forgetting to use await. Your method returns early. Mixing sync and async leads to deadlocks. Blocking async calls with .result or .wait defeats the purpose. Thinking async equal faster. It's only more efficient, not magically quicker. Good async code is about freeing resources, not speeding up math. Async all the way. There is one golden rule in asynchronous programming. If you start async, stay async. Once a method becomes async, everything that calls it must also become async, like a ripple. That's how .NET ensures consistency is called chains. So, to recap, async await is about freeing threads, not creating new ones. It makes your API scalable, not just fast. It's built on continuation and the task object. When you understand async, you don't just write faster code, you write smarter code. Thanks for watching .NET in Minutes. See you in the next episode, guys. Bye bye.